Hello, today I am going to discuss about manipulation of digital bit status inside input and output image memory via bits toggling process. Today's video is closely related to my previous video. So if you miss out my previous video, please go back and refer to my previous video because both videos are closely related to each other. Because we do not have an actual physical PLC to visually see of the effects on the external load when we manually play around the external switch. So we have to use the function of bit toggling to simulate the program. Okay, so what I means by this is, let's say we have a PLC. Example, we have a PLC. Sorry for my drawing, is very bad. Okay, this is a PLC. This is a CPU, Central Processing Unit or processor. This is a digital input. This is a digital output. So digital input will have many terminal points. Okay, digital output also will have many terminal points. Let's say digital input have terminal point 0, terminal point 1, terminal point 2. Similarly, for digital output have 0 and 1 to terminal points, and this digital input 0 connected to the external switch. Similarly, for the digital input 1 and 2, and digital output 0 is connected to external load, for example light bulb. All right, okay, this is connected to normally open switch, and this digital input 2 is connected to normally closed switch. Let's say this is a switch 0 and this is switch 1 and this is switch 2. This is light 0 and this is light 1. Okay, this is an actual physical PLC wiring connection to external load as well as external switch. Alright, so how do we simulate the PLC without actually own a PLC? As I mentioned in my previous video, in order to do so, we have to download and install and open the Emulate 500. So this software, Emulate 500, okay, this one, Emulate 500, is used to simulate the actual physical PLC. In other words, it acts as a virtual PLC. Okay, so in real world case, the switch 2 is normally closed. What happened is the actual current, okay, is actually flowing through this circuit into the digital input terminal point 2 to energize its internal LED and digital input load. So since the LED 2 is energized, what happened is this terminal point 2, okay, this terminal point 2 will be set to 1 because its LED is energized. As I mentioned, the input image memory and the output image memory reflects the bit status. 1 mean energized, 0 mean de-energized. This, if you notice, this virtual switch is normally closed, and thus the virtual power or current can flow through this rung to energize this virtual output coil. Because this virtual output coil is energized, what happened is, okay, you see this is a big one, which is terminal point 1. This digital output terminal point 1, internal LED will be energized through. Because its internal LED 1 is energized, so the digital output 1, here digital output 1, terminal point 1, will be updated from 0 to 1. As I mentioned, 1 means energized, is LED is energized. 0 means is LED is de-energized. Okay, so as you can see, 1 is energized. How do we simulate this? digital input to real world situation where the switch 2 is actually normally closed and the current will flow through this digital input 2 to energize LED 2 and update this terminal point 2 or bit 2 to 1. So we can click this one, right click and click the toggle bit. So toggle bit is used to toggle the bit status from 0 to 1 or from 1 to 0. In this case, here 0, once I click this one, it will change to 1, right? You can see, change to 1. So as we know, once this one is energized, when the actual current is flow through the digital input 2 to energize this LED 2, what happened? It will trigger the relevant virtual switch, which is normally closed virtual switch from normally closed to open. This is what will happen in the real world situation. Alright? Okay, now I want to simulate. Okay, the switch 0 is closed. Let's say I manually close the switch 0, this one. This switch 0, I will manually push it to close. So what happened is the actual current will flow through this circuit to energize digital input 0 internal LED and its internal digital input load. Since the LED 0 is energized, what happened is this digital input 0 will be updated with 1. Okay, so how we simulate? This is a 0, bit 0, which is this one, bit 0. We just need to click, right click and toggle bit, and you can see this will change to 1. And what happened is this, since the LEDs is energized, the digital input 0 LEDs is energized, what happened is it will trigger the virtual switch from normally open to close. How we know it's closed? You can see the green highlight. If this is closed, what happened is it means if the green highlight is appear if the green highlight appear, it means it is closed. Okay, the green highlight means it is in closed state. So now I want to simulate this switch 1 is pushed to close. So the actual current will flow through this circuit into terminal point 1 and energize its internal LED 1 and digital input load. So because the LED 1 is energized, this digital input terminal point 1, meaning bit 1 will be updated from 0 to 1. 1 mean LED is energized. 0 mean LED is de-energized. Because the LED 1 is energized, it will trigger the virtual switch from normally open to closed. Later you can see it will have a green highlight here, appear here. Green highlights means it is in closed state in the virtual environment. Alright, so how do we simulate? Okay, we just need to click and then right click and toggle bit. And then toggle, as I mentioned, is used to change the bit status. Okay, from 0 to 1 or 1 to 0. Now it's 0, later it will change to 1. After that, you can see this instruction will be closed. Then the virtual power can flow through this circuit to energize the output coil. And thus, the digital output coil, once is energized, what happens is it will cause the digital output 0 internal LED to be energized. Because the digital output 0 internal LEDs is energized, this bit 0 will be updated from 0 to 1. Okay, and thus will cause the digital output 0 internal switch trigger from normally open to close. Thus the current can flow through this circuit and hence will turn on this LO or light bulb 0. Okay, let's say I click this one, right click and toggle bit. You can see it changed to 1 for the digital input 1, and then this will be energized. It will change the bit status for digital output terminal point 0 to 1, and then this will be turned on. Alright, so that's it. Thanks.